Good afternoon, everyone. Thank you so much for taking time to join today's session. Welcome to today's session, Improving Data Center PUE, answer to all your questions. Chat and Q&A are open. We will run live polls during the session and Q&A at the end, so please stay engaged. So today with us, we have two industry experts as a panelist who will guide us through the session. This is Mr. Rajan Mehta, CEO of Efficienergi Consulting Private Limited. He comes with 24 plus years in power quality, reliability, and electrical optimization experience. He is also a chartered electrical engineer and part of national standard building committees like BIS, IEC, and also he contributed to numerous standards, including IS 17036, which is written by him. He is a regular speaker at global forums on harmonics, safety, and power reliability. He has worked with 2 megawatt to 150 megawatt of data center projects across the country and in the US throughout the project life cycle of data center. Then he has led 200 plus advanced power system studies like voltage stability, harmonics analysis, and power quality related across all India. He executed testing and commissioning practice for more than 300 megawatt of greenfield data centers. He is also an expert in L1 to L5 complete MEP testing and commissioning in data centers. Then we have Anurag Kumbhare, technical head of Aerosys Solutions. He is a ASHRAE certified building commissioning professional and NEPP TAP certified professional, practicing commissioning since 2014 and managing large HVAC TAP teams. He comes with 10 plus years of experience in HVAC commissioning across all India and Southeast Asia, delivering commissioning for large facilities, including 7,200 tons of data center in Malaysia. He achieved 2.7 gigawatts of annual energy saving through optimizations. And he is also an expert in L2 to L5 issue resolution and schedule acceleration in HVAC. He leads 40 plus members mechanical testing and commissioning team across HVAC and for complete APAC region. So why this partnership matters? So Efficienergi and Aerosys, a partnership that de-risk full stack commissioning. Complete MEP expertise under one roof, electrical and mechanical, from design review, power system studies, L1 to L5 testing and commissioning in electrical and mechanical, MEP risk management, audits, and PUE optimizations. Then there is regional reach, which is aligned to serve India, Malaysia, Indonesia, complete Asia Pacific region. The complete market intelligence, best-in-class instruments with 14 plus certified professionals like chartered engineers, NEPP certified people, ASHRAE certified professionals. Then we have a team of more than 40 to 45 plus electrical and mechanical engineers with experience in data centers for past 10 years, involved in design validation studies like load flow, relay coordination, arc flash, and has conducted more than 800 megawatt of data center rating. Then TAP conducted for more than 75,000 tons, providing deep experience in handling HVAC, which leads to their performance as well as snags during the various L1 to L5 stages. Then testing of entire infrastructure from HT substation till the socket level we provide. And for typical 4 megawatt data center, our team identifies more than 4,000 snag points on various electromechanical infrastructure. And then we are also working in the operational stages of more around 200 megawatt of data centers, where we focus on single point failure analysis, reliability studies, risk management, efficiency studies, which allows us a holistic view of what mistakes can be rectified during the greenfield stage itself. So our partnership with all your tender compliances, with all our certifications, we have combined experience of 40 plus years, and during greenfield and operational stages of data centers, we can help you. So these are the few numbers. Together, we have around 800 plus megawatt of design validation studies done for critical infrastructures, 75,000 plus of tons of HVAC commissioning, then operational 200 megawatt of data centers, SPOF studies, reliability, efficiency studies, and 4,000 plus snack points for a tentative 4 megawatt site. So I will request now Rajan sir to take over and head the session forward.
Thank you so much, Nikhil, for the introduction. And I'm really excited to have this session along with Anurag, of a friend, a co-entrepreneur, partner, many facets of our relationship. And so I have to thank Anurag also for being here, as much as I want to thank all of you who have taken time in this busy afternoon on a Thursday evening to be here. We do hope that we'll be able to give some knowledge which you can take back home and implement probably at your facilities. So, we are not going to be having a typical presentation-based session today. It is, you can imagine, more like a podcast where I'm going to be picking Anurag's brains a lot to extract information about how PUE optimization can be done, what is PUE in the first place, and so on and so forth. But before that, I was in Chennai just a couple of weeks ago, and there's a whole big buzz right around data centers. It's been around just I would say 10 years that India has seen this whole growth story around data centers, and we definitely are in a very, very good position when it comes to the growth that this particular segment has seen, the CAGR that we have been experiencing. And in that whole journey of this exponential growth that we're witnessing, where we were even talking in Chennai, that CDC event, W Media event, about reaching 3 to 4 gigawatts in the next 5 years, which looks possible. Currently we are at about 1.2 to 1.3 gigawatt of data center capacity in India, and having a threefold jump in the next 5 years is something that the whole industry is very bullish about. So looking at that, what is very important, right, is how much is efficiency in focus during all this construction that is happening at breakneck speed. There is no time, to be honest, while Anurag and myself and our teams are involved in the data center construction stage. We're going through the whole L0 to L7 stages. There is absolutely no time, a lot of times, to think about efficiency, to think about sustainability, to think about how will the data center be operational once it's operational. What will be its metrics or KPIs in terms of efficiency. So we thought, good time to take a pause and go back to some fundamentals, discuss about what does constitute a good efficiency for a data center, and nowhere better than to start from topic of PUE, right? So before I start, we dive into the hero in a way of today's discussion. I would just like to run a small poll, very quick poll, as to what is PUE, whether how many of you are aware about that. If you can run the poll, Nikhil. Yeah, thanks. I think you'll run the poll. So we'll just wait for 30 seconds to get your answers, which will kind of allow us to set the tone. So we almost have some, I would say, overwhelming number of participants. We still have some more participants to be voting. So yes, we have almost 70% people have voted. So we see that, okay, it's almost 80-90% now. I think almost 90% of you are aware of what is PUE, right? So that's a good first start for us to start from, understanding what PUE is. So let us demystify PUE before we go into too much detail on as to how to improve PUE. That is what is the crux of today's session. But what exactly is PUE, and what role does it play in deciding how a data center is efficient? So In very simple term, PUE, the full form is power usage effectiveness, right? And it is not only a single metric. There are many nuances to PUE. There are many facets of PUE which needs to be understood for it to be really for us to be able to really work on improving PUE before. So when I talk about PUE, the first thing that comes to my mind is how or at what how do you measure PUE? What is the mechanism in which you will be able to measure PUE? Where should you measure PUE? Though, so there are kind of three levels in terms of PUE that you need to be aware of, which are acknowledged in industry. One is PUE 1, PUE 2, and PUE 3. Right. So the first level 1, if you call it for PUE, is a basic level, which is measured. Okay, sorry, I should have given the basic formula for PUE, right? It is the total data center energy that is at the point of the utility providing the energy or whatever the source of energy is, divided by the IT equipment's energy that is being consumed, which is solely attributable to the IT equipment energy. So you have your total data center energy, which is measured at your metering point of all the energy sources that you're getting, divided by the IT equipment energy that is responsible for running the IT equipment. So now, given this background of this definition, as I mentioned, there are three different levels of PUE. The first being a L1, which is a basic PUE definition, where the measurement of PUE is typically, while the total energy measurement remains the same at the data center incoming metering point, the IT energy measurement is what differentiates these three different levels. The first level is done at the UPS output, typically. So that's the easiest place to measure. And maybe I'll just share a small graphic which will allow you to imagine the, yeah. So it will allow you to imagine the PUE better or where it is monitored. I hope my screen is visible. Okay. So as you see in this over here, this is your facility incomer. This is a typical data center facilities which is taken from the Green Grid, which is one of the very well-known papers on data center PUEs that has been written. So this is your A point, which is your utility incomer. At a level 1, we are talking about UPSs where you are going to be measuring PUE. So that is at level 1, right? Typically. So that anything at the output of the UPS, whatever is connected, is assumed to be IT equipment. And this is how you take a level 1 quick dipstick idea of where your PUE is sitting. To go further, where you are in an intermediate stage, where you want to do a little better, you want to have a better control over PUE, you want to go a little deeper into what are the energy efficiency interventions that can be taken up, you go into level 2, whereby that is at the PDU level. So you are essentially measuring the your IT equipment consumption at the PDU, which is in your data center. So wherever the PDUs are there, that's where you are focusing on measuring the IT equipment energy. And the more advanced and the most, I would say, one which is preferred if you really want to focus on PUE enhancement is at the level 3, which primarily talks about all the IT equipment input energy sources. So you're talking about your racks, you're talking about your storage devices, your workstations, your routers, switches, servers, all of these directly at the point of measurement. So you're going directly at the point of measurement at these places, all your meter rack PDUs and so on. That's the level 3. Now there is, while we're talking about the location of the measurement of the PUE at these three different places, what is very important is also the measurement interval or the frequency of measurement of these places. So at an L1, at a level 1 basic, one would expect that at least on a minimum of a per month, one reading at a monthly level, you will be taking, right, of your total DC energy and the UPS output. So that gives you a rough idea of where your PUE is sitting. At the next, you're talking about at the L2, at least you're going at a daily, or if not, the weekly, once a week measurement at the PDU output. But the condition, I would say, which should be adhered to is to ensure that you measure the same at the same time of the day, every day, if you're doing a daily measurement, or you measure it at the same day of the week if you're measuring on a weekly basis, to have a comparison with respect to PUE when you're doing. The next and the advanced one, which you're talking about the IT equipment level, ideally speaking, is what you should be having a continuous measurement at least at every 15 minutes intervals. That gives you a good enough idea about an annualized PUE figure. That is what you're more interested in. Again, PUE is best compared on an annual basis, and that's how it's supposed to be. On an annual basis, how is your PUE, what is it, and that's how you are going to be focusing on. So that's a very basic primer with respect to PUE. What are we talking about? What are we measuring? Why is it important? What is the formula about PUE, and so on. So at this point, I would like to pick Anurag's brains to talk about, give us some idea about, while we have laid down the definition about PUE, what is it inside PUE what it means for a facility. When I'm talking about PUE being 1.3 or 1.5, what does it mean to a facility? Is there something that you can give a more better idea to our users, to our attendees?
Okay. Hello. Good afternoon, all industry professional. Thanks for joining, and thanks, Nikhil, for a good introduction. Okay, so I'm sure like everyone is eager to hear about what different we are going to share about PUE, as everyone is quite aware about what PUE is. But one thing I'd like to appreciate and thank you, Rajan Bhai and Efficienergi team, for arranging this, because this platform is going to very helpful to exchange the ideas, because every facility owner is trying to keep the operation cost and the expenses minimum to get the most benefit out of their data center. And like Rajan Bhai, you explained what is the PUE. Okay, it was very well, but in simple way, it is like एक लीटर में कितना देती है. So same language is applicable here also. Like how much kW we are consuming to feed 1 kW of IT load. Okay, so that is how it is. And fortunately, there are many resources available to understand what should be the PUE. Okay, so the answer to your question, we cannot directly compare like 1.3, 1.5. First of all, we have to understand or the attendees or the joinees, I would say it cannot be directly compared. So first of all, it can be compared with respect to design. So one is like design PUE that we call DPUE. Okay, so you can always compare your own facilities PUE with DPUE. So that will be the right benchmark, because if you see the globally, nowadays they are trying to minimize it, and globally it is something like they are approaching almost 1.07 PUE or 1.17. As per standard, it is 1.17. It's coming, which sounds impossible. Okay, because nowadays the operational DCs which I see across India, that is ranging between 1.4, 1.6. That's how it is. 1.6 is specifically for the older facility. Okay, so if I call it like the difference between 1.3 to 1.5, I guess the difference is quite significant. So instead, I would like to brief it on lower range. Let's say both the DCs are same. One DC is running at 1.4, other DC is running at 1.45, keeping IT load same, because eventually IT load is the business, correct? Baki kuch karna nahi hai, means like other are only the ancillary equipments. So if we compare that, a difference of 0.05 PUE, let's consider that is a benchmark. We need to have some reference. Let's say we have a 4 megawatt, 4,000 kilowatt of IT load, common in both the facilities, and both facilities, one is running at 1.4, other one is running at 1.05. Okay, so with that difference, if we compare with the electricity rate of 10 rupees, So the major variable could be the HVAC utility only. Okay. So the HVAC utility, because other electrical losses, those might be here and there, those will be same. Lighting load would be same. So only the major variable here is the cooling load. Okay. So that will be directly related to the cooling efficiency and all. But this difference of 0.05 would go somewhere near to almost 1.5 to 1.7 CR extra operational cost. This small difference of 0.05. I'm comparing it with reference of operating a 4 megawatt of data center. So that's how the significance is. So it is very, very crucial, very, very significant. Even we can actually target a difference of 0.01 also, because 0.05 itself, it is that significant. So even if we could able to reduce it by 0.01, because if we are comparing 1.4, with 1.45, the difference is of somewhere around 3 to 4%. But even if we are targeting a reduction of 1%, that would also result in a significant difference.
Wow, that's quite revealing. 3 to 4 crore rupees of a back of the napkin calculations for just a 0.05 improvement in PUE. If I understand Anurag by correctly.
Sorry, Rajan bhai, it is 1.5 to 1.7 CR.
Okay, sorry, 1.5 to 1.7 CR, still
of difference, yeah.
Very, very big, significant difference of just a 0.05 improvement in PUE. So that's the power of what PUE is telling us about. And very rightly mentioned by Anurag, that comparison of PUE ideally is not recommended to be done across different data centers. Typically, what happens is when you go and talk to people, I meet in a lot of conferences and all, and people are exchanging the PUE between operational managers and so on. But that doesn't actually do justice to the comparisons. For your reference, I'll just share a very quick infographic on the state of the current PUE across the world. Okay, this infographic which you are seeing on your screen gives you an idea from 2007 to 2024 currently, what has been the change in PUE levels across the world. This is from a sample size of almost 500 plus data centers, which has been taken, and this is regularly taken every year. Uptime Institute, I think, is the entity who takes these statistical surveys. But what you see is on an average basis worldwide, this figure is only 1.56, which is what Anurag bhai mentioned as a typical figure for the Indian ecosystem. But comparing this or keeping this as a benchmark and feeling that, oh, wow, we are below 1.56 is not the right approach, because there are, like what I mentioned, is data centers with almost 1.2 PUE, 1.17, etc. PUE also, but their factors are different. Climatic conditions are different. Geographical location is different. Lot of different factors at play. So still, this gives us a perspective that where are we currently, and also what is important is if you look at the current last 5 years, the PUE levels of the data centers which have been commissioned in the last 4 to 5 years would be definitely lower than this figure. This is a summary of even older data centers, which is why this figure is where it is appearing to. So that's as far as PUE is concerned. And as far as measurement, we already spoke. Ideally, real-time measurements are best. So just would like to have a quick understanding poll from your side with respect to how frequently do you measure your PUEs? Does that, what frequency is something that you are currently measuring your PUE at? Would be good to have your insights. All right. So we have real time, we have annually. There are some who have not measuring it currently. That's nice. To see, we have 50% of participants have voted. We'll request more of you to vote to get a fair idea. There is a fair amount of participants who are having real-time automation in terms of PUE, while there are some monthly, quarterly also. Wait for some more participants to vote on their choice of frequency of measurement of PUE. Okay, so we just publish the result, and we can see that almost 40% of the participants are doing it on a real-time basis, but monthly is almost the next second best. So, and there are some who are not measuring it currently also. So that does give us a good idea that yes, there are the newer data centers which are having a real-time measurement system. Sometimes what we find in our experience, again, Anurag can help me with his views, is that while there are measurement systems, sensors and all installed, but computation of PUE doesn't take into account a level 3 measurement. It might be taking it at the PDU level or at the UPS level. That's what our experience is. So to really get the cream out of the benefit out of improvement of PUE, as I mentioned, level 3 would be almost better to enhance your real-time monitoring systems to bring to that level, or rack level monitoring, or metering at the rack, PDUs, strips, etc. of all your different IT equipments will be required. Right. So I think with this we can take a small slide, I would say detour, not a detour, but PUE, while we have spoken, I would also like to take Anurag's feedback because he is an ASHRAE expert, ASHRAE certification. He has multiple certifications from ASHRAE, and considering that, what is something that on a whole a data center should be looking at from an ASHRAE perspective? PUE is one of the metrics. What else do you think is important from your experience about improving efficiency for data centers through the lens of ASHRAE?
See, basically, if I want to say is on that side. So recently it is booming in India. Okay, so now also everyone is running after commissioning of greenfield projects. But now there we have enough quantum, which are like the DCs which are more than 10 years, those are operational. Okay, now it's a significant thing and the concern for everyone. And over the time, there's a huge change in technology. Okay, so first of all, we'll have to understand what is the pain area. What is the pain area for the operational facility? Because those were designed considering the older technology. Now even the technology is not only limited to the cooling, but now the servers which are coming, those are actually can work at an elevated temperature, let's say 30-35 degrees. Okay, but previously it was like the client was also asking for 21, 22 should be the room temperature. Okay, so maintaining 22 room temperature and maintaining 29 room temperature, it's itself a big difference. Okay, so if you ask me about ASHRAE, so ASHRAE has given the terminologies, the ASHRAE has given the standards. Okay, so one significant thing, if everyone would like to note, that ASHRAE 90.4 is there. Okay, apart from PUE, but because this PUE is like a basis, a benchmark which a designer defined. Okay, but what are the backend calculation to arrive at the PUE? So those can be referred from ASHRAE 90.4. So what ASHRAE 90.4 says that for, let's say, for mechanical or for the cooling things, this should be the MLC. So they call it as MLC, like mechanical load component. Okay, so this should be the mechanical factor. So if you talk, so ASHRAE has clearly given a table with respect to climatic conditions. Okay, so if we refer like if I want to give you an example, if we are referring it to India with respect to Ireland. So for Ireland, MLC is somewhere around 15 to 17%. Okay, means the mechanical load would be 17% of total IT load. Okay, and same if we compare the it with Indian region, that would go somewhere around 26% to 27%. So here itself we can see a difference of 70%.
Right.
Okay, so those references can be referred easily. Even so, I would suggest, or I would ask the industry professionals should refer this document. It is very easy and it is very useful. It's a whole crux is given in a very single document. Okay, this is hardly like 20-30 page document. Okay, but it is very useful. Also, that document is given with ELC, that is electrical loss component. Okay, what should be the percentage loss? Okay, allowed losses considering the 90.4. And nowadays, there are many DCs who are actually planning to comply their design to 90.4, because yes, the design has been done, but design basis is something the typical which we are using, like ASHRAE 90.1, which is regularly used to design the HVAC. But now there is the upgraded version. They have also incorporated there's a combined document which calls it for the mechanical and electrical board. Okay, so these two documents will be very useful. One is ASHRAE 90.4 and other one is your ISO 30134-2. Okay, this will be very useful to understand what should be the PUE with respect to the region. Okay, that is one aspect I would say. But now there is one other part is like, now also there are new diseases are coming up, but I see there are multiple diseases who are actually approaching some design variations. Some are actually implementing a renewable energy, some are implementing heat recovery things, some are implementing free cooling things. So the PUE will vary. So the mechanical component which I am talking, so that is something related to the design calculations and all. Okay.
Okay, so I will like to stop Anurag here to not jump into my my next topics. So I'll stop you there. We'll talk about different interventions about cooling very shortly. That is going to be the crux of the session today. So I think from a standard perspective, that's a great primer that we got from your side, especially the ASHRAE 19.4 and the MLC, which gives an overall view about the data center efficiency and not just focusing on PUE. Those are also important aspects, but I guess we'll have to do a separate session for that when the time permits. In the meanwhile, one question which we received from the audience, I would like to take it at this point, and coincidentally, we had a poll for that. It's a seemingly simple question. I would like to ask the audience, if I can request Nikhil to run the poll. If this question is about if your data center is switching to a greener source of energy, right, like solar, wind, anything else, will the PUE reduce? So that's something to get an idea. So say if I'm not using thermal power plants to power my data center, if I'm using, say, green source of energy, renewable power, will my PUE reduce? We have a very nice competition going on between the yes and the no's. The no's seem to be winning. It seems counterintuitive, isn't it? If you have green energy powering your data center, you should be having a benefit of that, right? So, okay, so we have almost 70-80% of people have voted. So we'll publish the result. An overwhelming majority, I mean, not overwhelming, I would say 60% have voted for no and 40% have voted yes. Now, the answer to this question is actually no. Even if you are going to be using green energy to power your data center, the PUE will not reduce, because it's the source of energy where you are optimizing. Your overall energy consumption that may be optimized, you are paying lesser, etc. That's a different thing. But PUE is talking about the efficiency of your data center. How well are you using your energy from wherever it is coming from? How efficiently are you using your energy for powering your IT equipment? That is the crux of a PUE. That is why that metric is important for you to understand, that it is talking about efficiently using whatever power is being given to your data center to power your IT equipment. So I hope that question has been answered. It was part of one of the participants' questions. So let's move forward then. We talk about what are the biggest contributing factors with respect to PUE. Right now, there are many different factors which are part of PUE that can contribute to PUE, and There are 4 of them. If we come to that, I mean, there is one more poll, but I would let the poll not go right now. Have you already done it? Because I'm worried people are gonna bash me up if we put too many polls out there and not give knowledge. So have you already put the poll? Not yet. Okay. So the few elements which are part of the PUE contribution are cooling infrastructure, right? That is the biggest contributor which takes into account PUE, right? The next is power infrastructure, like your transformers, generators, switchgear panels, UPSs, power distribution PDUs, your ATS, STSs, distribution cabling, lighting. Then you have your security, BMS, all the other ancillary loads. So all of these together, they factor in and they contribute to your PUE. Obviously, cooling infra takes the biggest chunk of the contribution to cooling, which is what we will speak about very soon, because that's the area where I would say 80% of the efforts need to be concentrated to achieve a lower PUE. But before going to that, and where I'll take Anurag's experience, there is a lot of power infrastructure. So we had a question which was talking about can we not measure PUE or IT equipment energy at the input of the UPS? Now, if we do that, the losses that the UPS is having, the efficiency losses that the UPS brings to the whole data center energy consumption are being factored in the IT equipment energy, which is not right, because those, as much as you can optimize, the lower your PUE will go down. So the point is that all your power infra, such as transformers, your generators, your LT, HT panels, switchgear panels, your UPSs, your PDUs, your efficiency of your PDUs, all of these matters a lot. And the better, the more efficient you can get these, the better improvement your PUE will be by having your numerator, which is the total energy consumption of your DC, going down, not the denominator, which is your IT load consumption. So you can reduce your PUE by improving the efficiency of all these power infrastructure equipment. Now, there can be strategies like harmonic mitigation. We have seen a lot of cases where UPSs are having a lot of distortion, which causes the efficiency to go low. We have cooling fans infrastructure, EC electronic computed fans or drives which are there where harmonics seem to be very high. These again play a role in reducing efficiency. So strategies to mitigate these harmonics or to mitigate I2T losses by right sizing of your infrastructure. So during the design stage, Anurag mentioned about DPUE. So at the design stage, if you're able to run load flow studies and understand what is the losses in your entire data center, right from the substation all the way till the rack level, through the cables that are running, through the switchgear panels that are running, PDUs, switches and everything, and select the sizing of your conductors appropriately such that the voltage drops are minimized and so on, that will contribute a small bit in bringing your PUE down. But the lion's share is the cooling infrastructure. So I would like to get into the cooling infrastructure, for which I'll request Anurag bhai to take a small, very quick primer on the various cooling infrastructure or technologies that we are seeing today in current scenario in hyperscale or colo data centers, and then we can go into pros and cons of them.
Okay, so majorly there are 4 things. One is like very much popular, that is air cooling. Okay, so now there are some minor variations that are trying to take the benefits of ambient conditions and all. So one is air cooling, other one is your liquid cooling, and third one is immersion. Okay, so in air cooling we can actually divide it in 2 parts. One is normal the conventional one, where we use the chiller or the DX system to cool the air to supply to the data hall, and then other one is like the free cooling. So free cooling is basically only we run the fan, we take the fresh air from the ambient which is at lower temperature, we supply it to the data one, and then it gets exhausted. Okay. So the major difference, as per the study and analysis shows, if we keep the free cooling aside, and if we try to compare the chill water systems directly with the liquid cooling system, hardly there is a difference of 3 to 4% of energy saving. Okay. I'm not very much sure about the immersion type, but yes, immersion would be the most efficient system. See, I'm not, I haven't got any of the data for the immersion one, because the immersion, one thing I can understand, since it is the direct cooling to the chips, obviously that will be with the very minimal losses. There won't be any what do you call the phases or the heat exchange things. It will be directly exchanging heat with the chip, so that will be the most efficient one. But yet to get the data, so there is no data available for the things. Even I haven't got any hands-on on that system. But yes, the liquid cooling is booming nowadays. Even a 3-4% of energy saving on cooling side for a big hyperscale thing would be a significant part. So considering the number of equipments in cooling, liquid cooling, those are getting reduced. Obviously, the maintenance will go down. So that's how these 4 types of cooling systems are available. You can say the majorly 3 types of cooling systems are available in the market. And the energy efficiency varies from concept to concept. So even if we talk about the chill water, it can vary if it is water cooled chiller or air cooled chiller. If it is a small DX system, it will be more inefficient. So it varies. And the best, considering the location, nowadays in India, you can see the most of them are using air cooled chillers.
Can you run the poll for the? Let's get an idea from the participants as to what kind of cooling are they using, to give them a better perspective of going into a little more detail. What kind of cooling is something that you are using in your data centers would be really insightful for us to understand. And then we can go a little more deeper into strategies and areas for improvement as to how do we minimize, and practical experiences. That's something we can go into in more detail. So we have largely air cooling seems to be the flavor of the season. Okay. So almost a large majority have air-cooled chilling as their primary means of cooling infrastructure, with water cooling second, and some of them in row, as well as an immersion. That's also interesting, Anurag bhai. We have some immersion, one of the participants with immersion cooling also. So considering this background, I would request Anurag bhai, if you can go a little bit deeper into the infrastructure component of an air cooling, and strategies for mitigation or strategies for efficiency improvements in these different components of an air cooled chilling air cooled infrastructure.
Okay, so basically, sorry for the interruption. Yeah, so basically, if we talk about the systems now, like I mentioned, if we are having a small DC, let's say, so even this ASHRAE 90.4, it aggregates in 2 parts. One is below 300 kW, other one is above 300 kW. Okay, so obviously above 300 kW adds offer more benefits, because you can go with the bigger capacity of equipment and lesser number of equipments. Okay, so that is very much important. If the number of equipments are going up, initially it will offer the better efficiency, but over the period, operation and maintenance, it will result in poor efficiency and all that things. Okay, so water cooled chiller is the conventional one, which offers the best what do you call the efficiency. So we have some data. Let's say one DC is having water cooled chiller at same you can say same city. Okay, same IT load. So the DC with water cooled chiller and DC with air cooled chiller, the difference is coming of almost 0.12. Let's say the water cooled chiller is with 1.4, then air cooled is coming up with 1.52. So that's how big it is. So 0.12, like I mentioned at the beginning, so you can simply multiply it by the factor. Let's say if one PUE is costing you somewhere around 1 CR, then a difference of 0.12 PUE would cost you almost 10 to 12 CR of operation cost. So that's how huge it is. Again, it depends on the size and the IT load variations and all that things. So that's how the conventional things are moving now. So yes, there is a lot of opportunity for optimization for the conventional side. Okay.
Anything specific, Anurag bhai, you can give ideas or your experience on specific components of the whole ecosystem of cooling, say for Krahus, for crack units, or for compressors, for chilled water pumps. Any specific interventions or any mitigation strategies that you can?
Mitigation strategy. See, basically, when initially everyone is aware, like initially the cooling was done through false floor. Okay. So through false floor, the majorly Krahus were installed, okay, to cater those kind of requirements. So what is our observation? The air balancing is one of the most critical part when we have the false floor system, okay, compared to the flooded system. Okay, so false floor system, then even though there is no enough load in a specific rack, so we have to supply the airflow, and there is a lot of uneven distribution across the floor. So even though there is one point where there is no much flow, so there is that imbalance system I have seen, and the operational people are actually running at the full speed to just to cater that one farthest point which is not getting the enough flow. Okay, so this kind of multiple like if inefficiencies I have seen. Not only that, I have also seen that like below false floor, lot of cable trenches are there, utilities are running from here and there. So core cutouts are there to allow the utility to go pass through the walls. So those are also open. So a lot of infiltration, and infiltration is one of the killing factor in inefficiency, because efficiency, because if the ambient load which is unfiltered, high humid things, and that is getting infiltrated in your facility, that is actually adding unaccountable latent load. Okay, so that's how there was a one case where we have identified the opportunity of almost 18% for energy savings. So the cases and the story for DC to DC is different. So it is very specific to the site. And yes, considering the old infrastructure, there are multiple opportunities.
Okay, lovely. And what about COP, EERs for chillers? Any light on that? Coefficient of performances or energy efficiency ratios? How is their operation optimized, and how does that again affect you?
So, like I mentioned, if it's a significant capacity of DC where we have a big equipment, so always the maintenance of big equipments is easy and it is attainable because you have enough space and everything is there. When we have number of units, number of Krahus, outdoor units are there, and initially the facility looks very good, but over the period it deteriorates, and the cleaning and all those things, sometimes it is challenging considering the space constraints and all that. So that actually impacts the COP and ER. And as I given you the clear comparison between water cooled chiller and air cooled chiller, so there is a very significant difference. And again, the water cooled chiller has got some limitation with respect to the locations. So if it is something like Mumbai, or yes, in Mumbai also there are DCs which are installed with the water cooled chiller, but water cooled chiller are having some challenges considering the humid areas. Okay, so it's not that, but that it won't work efficiently. But down the line, if you compare both the things, it not only directly, I would say it's not correct directly compare with the COP. If it is a dry area, we can compare directly with the COP, but in humid area, We cannot compare it with the directly with the COP directly from air cooled chiller to water cooled chiller, because on water cooled chiller you have again more maintenance on the cooling tower side, the water treatment, the chemical, the drip losses are there. So multiple factors are there. But if you ask me to compare in a dry area, so yes, the COP with the water cooled chiller is much better, which offers at least a 12% better efficiency compared to air cooled.
Okay. Okay, great. And one other factor I think which plays a very important role in PUE is the density of the IT load. Like generally, it is not going to be remaining constant, especially with the AI workloads which we're expecting. There is going to be significant variation in the IT loads. So that is also going to play a factor in terms of the how the cooling system is going to adapt to that variability in the IT load density, and consequently the PUE is also going to get affected, right? So any thoughts on that?
See, you'll have to, when you're talking about density, you'll have to think on a direction of heat transfer things. Okay, so heat transfer is very simple. It is something like your electrical only. Higher the potential difference, lesser the losses. Okay. Lesser the potential difference, higher the losses. Here it is also same. If you are having lesser density, it means there is no enough heat load, and we are supplying air to carry away the heat. Correct. Okay, and if there is no enough heat load, there will be less temperature difference. Let's say if supply air is at 20 degrees and out air is coming somewhere at 25 degrees, and the system is designed for 29 degrees. So it is not like that the AHUs or the chiller is going to moderate. Yes, it will moderate, but those all heat exchangers will be working across low delta T, and heat exchange efficiency across low delta T is poor. So that's how the mechanical system gets affected when we have the lesser density. It's not only that, then let's say we have a fan. Fan is also having their own minimum limitations. We cannot go below certain RPM. We have a lower bracket as well. Okay, so those are certain limitations when we have to cater for the lesser density data halls. That's
Okay. Okay.
how
Okay.
it impacts in energy, and that PUE cannot be directly compared.
Got it. Got it. And last but not the least, I mean, if you would like to share any real life case studies on what was the situation before you did an intervention at a particular DC, and what interventions you did and what were you able to achieve post. If you want to share any insights on that, that would be great.
Okay, so basically, there are multiple cases. And because of a lot of work pressure, the H2C, the handover, and all those things, there are some of the tests which are being compromised or carried or tested in short time, because testing, it's a very comprehensive thing, and it takes time. When we talk about the water balancing, air balancing, it's very, and we have a big systems, the big piping network and everything. So the same thing, like we identified, they were running the pump at higher frequency to meet the farthest point pressure. But the farthest point pressure, if we go along with calculation, those were coming somewhere around 130 kPa, but actually they were running at 180 kPa. That's how the difference was. And instead of 130 kPa, if we are running the system at 180 kPa, that's a huge pumping loss. So we identified the things, we rebalanced the complete system, why it was there and why it was happening. So post that, we were able to save the pump power at least by that was by 32%.
Wow. Okay.
Yes,
that's significant.
Yes, and on air side also there are multiple things, the leakages, the damper operation problems. So likewise, but yes, on air side you won't get that much of opportunity for savings. But yes, it was there, hardly 3% of energy saving was there. But that 3% of energy saving was without any investment. We just did the small fine tuning, and this rectification was done by in-house team only, because that was easily doable. So the 3% was with very minimal ROI.
Got it. Got it. Great. I think that was very insightful. we are almost, I think, at the end of our session for today. One question I think which I would maybe take up is, what factors do we need to consider if we want to modify air cooled data center into a liquid cooling data center? First of all, is that practically possible? And if yes, what factors can be taken?
So that question is to me.
Yes.
Okay, so I am not really sure. You can keep the primary cooling system same, but I guess yes, all server racks will have to change, which is practically impossible. You can
Yes.
keep the source of cooling same, but the other side, which is the core of data center, this
Yes. So it is, in a way, I think it's almost next to impossible, because it's not just the cooling infrastructure; the whole power infrastructure will also have to be modified. It's as good as designing completely something from scratch. So I don't think that's going to be a really practical thing to be done. Great. I think is there? Okay, there's one more question. Sir, what is core calculation of design PUE? Which we are getting from the consultant? That is one question which has just come in. Can you throw some light on it, Anurag bhai?
What is core calculations of design PUE, which we are getting from consultant? Okay, fine. So basically, the PUE, one thing is very clear, that IT guys will tell you like, this is what is going to be my server load. Okay. So then in reference of that, what strategies consultant is offering, that is more important. Okay. And what is the location? So this all data you should get clearly. And you can actually refer to the ASHRAE 90.4. They have given what should be the cooling load component. Okay. On that basis, you can actually refer. And let's say the cooling load component is 0.25. So one is your IT load, 1 plus 0.25, that would be 1.25. Apart from that, there will be other utilities like lighting load, BMS, other ancillary things.
Power.
So accordingly, you will be getting the total design PU of 1.35, something like that, and that you can compare.
I think another factor which will also contribute to this DPUE will be your loading percentages. So they will be doing, I think, ideally should be doing the calculations on multiple loading scenarios, because that will play an important role. What percentage of your active IT load is there? What is the idling percentage? And your cooling load, etc. So the loading also, diversity factors will also play
Yes.
another role.
That is there. Means like, let's say 25, 50, 75, 100. That is the standard practice they follow.
Yes. Great. I think we are almost at the end, and I would at this point, if I'll invite, if any more questions are there from the audience, please feel free to ask. And in the meanwhile, would definitely like to once again thank our industry participants for taking the time out and on this important topic. We probably will continue on this thread, going a little deeper into some more concepts and maybe some more informative case studies or something in the next sessions. And if there are no more questions, because I think we've answered most of them, if there are no more questions, then we can call this the end of this webinar. Okay, I think we don't have any more questions. So thank you so much, everyone, for joining. It was a great pleasure having you. Thank you, Anurag bhai, for your time and expert knowledge on this. And would love to see all of you once again once we go with the next thread. Is there a question? Okay, there's one question which has just come in. What should be the temperature which we need to maintain for electrical rooms? Anurag, if you want to take that one.
Yeah. So basically, as I see, there's no specific things like people are still running around maintaining 23, 24 degrees. So even the temperature of electrical room is 35. That is good enough. Because most of the OEM provides with that, means some of the even panels are coming which can work at 45 degrees. That is also okay. But on an average, I have seen like they're maintaining 35 degrees, which is very much efficient and safe for the electric panels.
Yes. Because there is a lot of buffers, a lot of design buffers also, which go into consideration. So for sure, efficiency wise, if you have a good air exchange happening in those rooms, I think that's a critical factor more than the temperature.
It's normal ventilation room.
Right.
Ventilated room with the forced ventilated rooms.
Right. With a minimum number of air exchanges happening
Yes.
every hour or something, that will be a great way to ensure long life of an electrical equipment. So thank you, Mayurji, for the question. And anything else anyone wants to ask? We can still be here for a minute. If anyone else has any more queries, please feel free to take advantage.
I hope this was fruitful, and if we are getting some more challenging questions, at least we'll get chance to scratch our head and we'll come up with the solution, even if we are not able to answer at the moment. But yes, we'll come.
There is one which has come in. Your adiabatic for chiller system, does it improve the PUE?
Obviously, it improves the PUE, and there are many DCs who have actually implemented this concept, and they have got the benefits of almost 8 to 10% through energy savings. This is for air cooled chillers. It is helpful, but yes, there are some limitations. If it is coming pre-fitted with the chillers, that is quite easy because you get enough access for the maintenance. But if it is retrofitted and if you are not having enough space for maintenance, then that becomes a challenge.
And if you want to, for the benefit of others who do not know about adiabatic systems, can you just very brief?
Adiabatic is something like now we are having a normal air cooled chiller which is in play, which is placed at the terrace. It is getting the ambient air at the inlet. Okay, so ambient air which is at dry air. Okay, so what we can do, we can reduce the air temperature by adding some moisture, and we can bring it down till WBT, not exactly till WBT, but yes, adiabatic stands for till WBT. So you can consider a drop of 5-6 degrees. Okay, that can be done with the help of pads. The pads, which are simply the operative cooling pads, which everyone must have seen in normal domestic coolers and all. So the same concept they apply it here. So some are with the mist type of cooling. The bottom line is only adding moisture to drop down the temperature, to bring it down to the WBT. That's how the concept is. Whatever is the media you use mist, you use what you call nylon sheets are also there. Then cell deck pads are also there. So these are the different technologies they are using. But yes, it is beneficial, and many of DCs have implemented this.
Okay. Great. Thank you, Vijayji, for the question. I hope we could answer that. And okay, one more question is, can we consider diversity factor in PUE calculation?
No. There is no diversity directly related to the PUE. That will go with your operation, whether it is n+1, n+2.
Yes.
Okay. If it is n+2, and if system allows, you are using all the equipments at a time to improvise the heat exchange and all that. So basically, that works better on the chiller side. If you are restricting your chiller not to go beyond 80%, and you are adding up your standby to cater the max load requirement. So at 80%, the chiller actually works better with the efficiency, because post after 80%, 85, 90, 95%, the efficiency of the specific power consumption deteriorates. So there you can get the benefits, but not directly with the PUE calculations, because DPUE won't be with that benchmark.
Yes. And just to add to this, PUE, remember once again, is a measurement ideally speaking, energy measurement, kWh measurement done on an annualized basis. So the actual energy measurement you are taking at the data center's source of energy point, the total energy consumption, divided by your annualized consumption for your IT equipment. So your diversity and everything anyway is all factored into that. Whatever you are consuming is what you are going to be measuring, and that is going to be your PUE calculation. So in DPUE, yes, like Anurag mentioned, that plays a role. So thank you, Vikasji, for the question. Okay, then I think it's almost 10 minutes past our intended deadline, and as Anurag mentioned, it'll be great. You can definitely mail across your anything, which will you can see it in the chat box coming in, and we will definitely make our attempts to answer them as much as possible. And once again, thank you for your joining this session, and look forward to see you all again. Thank you.